What's up? Good morning. Welcome. Hope everyone's doing okay. So, yesterday I finished up what I've been working on for about a week and a half, 2 weeks or so, which is converting the existing Gunslinger framework over to a header-only library. Did a release about it, made an announcement. Let's see. Can you turn the volume on the mic up a bit? Yeah, let me look at, let's see. Try not to do too much. Let's see if that helps a little bit. I think so. Yeah, okay. That looks fine. I don't want to go too high because I start talking a little louder and then the gain gets kind of crazy. So, but that should be better. Let me know if it is. So, this is Gunslinger now. If you've looked at the library previously in the past, it was a lot more than this, right? So it had source folder, include folder, all that kind of stuff. And it had an examples folder. So now what it is third-party stuff that's included. Mainly header-only libraries in here. And then we have Gunslinger itself, the main library. So it's quite large. It's about 5,000 lines of code. And then we have our implementation for different subsystems in here. And then our util, which is stuff that sits on top of Gunslinger that are optional utils that you can include. This is going to be the core framework. It's not going to change too much from what it is right now. Really what's going to change are adding more utils in the future, optional utils, maybe adding some more implementation stuff. But for the most part, this is going to be it. What I need to work on today, if you've looked at the title of the stream, I need to start doing converting the previous examples that I had over to this new framework. The examples really work as living documentation for the framework itself. Just having written documentation gets static, it gets old. So the best way to keep up with your documentation for your code, your library, whatever you're working on, this goes for if you're at some job or something and they want you to write documentation, I would highly suggest that you suggest to them to say that you wanted to use written examples instead. Because written examples, I mean, what's the main purpose of documentation is to show off how to use what it is that you've written, right? Which is great. If you have written documentation, the problem with that is that it gets stale very quickly, especially if you're updating your library as quickly as I'm intending on updating this. The good thing about examples is that you make a change to your library, you recompile your example code, and it doesn't compile or it doesn't run correctly, then you have firsthand knowledge right then and there that your documentation is out of date. So you go and fix it, and then your documentation is now up to date because the example runs correctly. So with that being said, what we're going to do a couple things. First off, I made a couple of changes yesterday. Someone pointed out to me that some of the code wasn't compiling correctly, and it's because some inline functions weren't inline properly, so it was getting redefined. So that means that the project template itself is not working correctly. So I'm going to go ahead and change this and update it real quick. Push that so that it's actually correct, and then we can continue. So make sure this all compiles. Okay, so that's fine. So when you download the project template, this is what you'll see. This will be your starting, your welcome screen. Okay, so what we need to do, let me open up. And this should be all up to date, but let me, just in case. Let me see if this will compile with VS 2019. What I've seen, Dangerous, is that it's actually an issue with the STB lib. It's doing something. There's something with VS 2019's implementation of the intrinsic library, and I haven't taken the time to dig through it enough. I did a quick look through it, and that was about it. So. So as far as I can tell, it's not anything in particular with Gunslinger itself. It's with the STB lib that I'm using, unfortunately. So solution might be to either drop STB lib or figure out if there's a way to get it working with 2019. But I've seen other people complain about it as well. Okay, so Gunslinger's fine, this is fine. Let's go ahead and just change out this real quick. Okay. Yeah, you're right. Shouldn't be a big problem, but I'll just do this just to clean it up. It's not going to change it won't change any of it, but you are right, that does look unclean. You can use C-line and MinGW. Yep, so it compiles to MinGW. Again, it's header only, so as long as you have the right compiler settings for whatever you're using, it's whatever. Use what you want. That's the ideal situation. I don't want to lock you down to something, so. Okay, so let's update this real quick. Also, I need to get better at writing or figuring out the syntax for a lot of this markup. That's something I need to take some time to get better at. Delete this guy. Oh shit, do I have the bin in there? Damn it. Delete that. I don't want that. I just want these, so. Okay, this might take a second, but in the meantime, we'll let that go. Let that run for a second, Maybe this is a bad idea. I'm sitting here uploading something while I'm streaming, but let's let that go. And now what we're going to do is clone this and then start working on an example project. So actually the ideal would be to, so let's see, the ideal would be to create a template here. Let's just call this examples. And then we'll include the repo in here for Gunslinger. So let's say inside of third party, inside of include, then we'll include the Gunslinger repo. And then all the examples, we'll just use that code to compile. That'd be the easiest way. Or maybe what we'll just do this. Just so I don't have to pull anything down. Let's copy it. Okay. So now let's open this up. Okay, so we'll have our Gunslinger examples here. They're going to include repo to GS. So as we make changes, we won't have this. What we'll have instead are folders that'll have different examples inside of them. And then inside of each of those, you'll have a procedure. And then I'll probably have some bat files or something like that on the outside that's, you know, compile all or something like that. Try to figure out the best way to organize this. So let's go ahead, delete this folder. Okay, so first one we're going to start out with is just the hello.js example. And then we'll do like a triangle. Maybe I should number these. Like, what's the best way to name these? Should it be 0? I don't know. Okay, so include directories are going to be different. So it's going to create a bin directory when you do this, and then you're going to go back to levels, third party include, and then you'll have GS, and then we'll have a source folder. And inside here, we'll just have a new main. All this looks okay. Okay. And that really should be all we need for that one. Exit this. Okay, here's our examples. Hello GS. Should be good, then we run it. And then we have our application. Of course, we're not doing anything. So if we look at the previous, I have way too much open. Photoshop open. Let me just close all this stuff. Development, let's close that. Okay, that's fine. Main Gunslinger being open's fine. The project template I can probably close. Don't need that right now. Okay. So what I do want to open up, however, is the previous examples so that we can use that as a let's see, why do you use bat files and bash scripts instead of a make file? I just find them simpler. Simpler to use. Feel free to use whatever you want, you know. For these examples, I might go through and add CMake files to them. I might add make files. I might do all that stuff. Since Gunslinger is just a header-only library, you don't compile it. You don't have to. You just include it in your project or whatever, and then go from there. All right, so here's the examples. Let's just open this up. Some of these I might not take the time, at least today. Well, definitely not today. To go through and rewrite. Like the terrain one, I don't know. There's just a lot in there. Sand simulation, maybe. Probably. Maybe I should, since it is the most popular video I've done. Maybe it would make sense to redo that. Okay, so let's look at Hello.js. I definitely want this. So just an explanation of what this example is. That probably could be it. and the suppress escape. So let's do and that could be our basic. That's interesting. Oh, that's right, 'cause I'm not giving it a window title. Why do you prefer C99 over the most recent one? I'm assuming you mean C11. The reason I prefer C99 is because C11 is not supported by most compilers. Which is a shame, because it does have some interesting things in there, especially regarding generics. But it's not supported, so. Okay, and then we should be able to open up let's just open up git bash here. So yeah, no problem. Windows, compile, GW. Okay. So I don't think for Hello.js there should be anything else other than this. It should just open up a simple window, creating the most minimalist application description with the ability to have an update function so you can escape the program with the escape key. I think this is it. You know. So it's 10 lines of code, more or less. All right. So now let's move on to the triangle. This is where it's going to get a little more involved. Because we're going to be doing explicit rendering. So maybe I should call it Hello Triangle. I don't know. Oh, I already have it. For this, let me go ahead and make sure that all these procedures are okay. That looks good, and that looks good. Okay. So let's close this. And now all we have to do is just change this. So we'll just change it to a simple triangle. these are okay, weren't they? Yeah. Okay, and our source doing this. So again, let's open up our example. Triangle source. No, that's the texture. Whoops. Explicitly construct GPU resources to use for your app to render a basic triangle. So we're going to construct vertex and index buffers from user-defined declarations, construct our shaders from source, render via command buffer, construct pipelines. Which maybe there should be a tutorial for constructing pipelines as well. And then shaders, I don't know. It might be a good idea to do that. Because this is gonna, like jumping straight into all of this stuff might be a little overwhelming. Especially for people that are coming directly from implicit rendering like OpenGL. But we'll try it. Let's do it. So let's go ahead and split this a little bit. And I'll collapse this stuff. Go away. Thank you. Try to make this at least somewhat easy for you guys to read and not have to jump back and forth between windows. What does that look like? Does it look like shit? Yeah, it looks okay. Someone also gave me, Unity gave me the idea to record this at the same time that I'm streaming, which I'm doing right now. The reason being that I can chop it up a little bit and then use this as separate videos to go over like examples. So I'm gonna try that. Okay, so no. Let's go back and forth. So we're gonna need this stuff here. To do any rendering, you're gonna need a command buffer. And then we're going to need our VBO, which actually this is a handle. We'll need a pipeline. We're going to need a shader. What else? So here I'm using uniforms in the previous one. I might not need to do that. Let's just copy this shader code over. So for this shader code, we are using a uniform color. Let's just go ahead and do that. Just this shows how to do uniforms as well. So, to a uniform block. Is that really what I call it? I might want to change that to a uniform buffer. Bind bindings, you're passing in a uniform buffer. Yeah, this is why it's good to go through and start doing examples, because even when I'm doing this, I'm seeing some stuff that I don't like, and I might want to change. Just naming stuff is difficult. So this function is invalid. Doesn't really work. Doesn't really do anything because you bind your bindings. You bind a uniform buffer in order to do that. You don't bind uniform blocks directly. And calling this a uniform block, which I don't like. Let me look at some previous stuff. It wasn't this, there was a refactor. So projects, the refactor, and then this has some stuff that I'm interested in. Okay, so I call it a graphics buffer because it just returns to you. It just returns you a handle, which that makes sense. Which, yeah, so it's just buffer create. Yeah. Okay, and then returns you a handle to a graphics buffer. That's correct. So this stuff right here, this is just legacy, or not legacy, but it's unused code that I was writing whenever I was designing this API that doesn't actually do that. You delete the buffer, and then that does what it needs to do. Same thing for this. You don't bind a uniform block directly. So what I'm going to do, bind uniform block. It's gone, and then make sure in the graphics implementation I don't do that. Well, I do. There's no reason to do this because I don't look for this. Yeah. Yep. Okay. So let me push that up and then I'll pull it back down. mutation. Okay, and then inside of here, we need to update this. So let's go back to example. And then we'll just pull. So now it should be done. It looks like it is. Cool. Okay. Alrighty, so let's move along. So it's not a uniform. This is a buffer, just like it should be, because it's a uniform buffer. Which we can call this what our uniform is, so we'll just call it uColor. Our shader, our VBO, uColor. And that should be it. Okay. Okay, triangle. We'll need an initialization function here. We'll need an update. So we're going to initialize all of our resources. Do that. Now we're going to need to fill out all of our stuff for all of our graphics resources. So let's go ahead and make the vertex buffer. So for that, we'll need a vertex buffer declaration. Actually, it's just a graphics buffer declaration, or descriptum. Bleh. So we come in here, we actually do something like that. It's just right here. So our VBO is graphics buffer create. And you pass in a pointer to this. We can do this on the stack. Okay, and then we're going to need to fill out the type for the buffer, the data that we want to pass up for this buffer to create, and then the size in bytes of the buffer. Okay. So let's do our vertex data for a triangle, which we have an example of that here. We'll just copy this. Okay. We don't need an index buffer. It's not that big a deal. It's a vertex buffer. The data is the vertex data, and then the size in bytes is the size of the vertex data. So that just creates a GPU resource for us for all our vertex data that we're going to use to render the triangle. Again, we don't need an index buffer, so we don't care about that. We'll do the pipeline here in a second. For now, we need to create a couple things. The first being our shader. So for the shader, we're going to create a source descriptor. So it's just an array of shader sources where you pass in the type and then the source. Okay. And then using that, we can actually create our shader. Which it takes a shader description. Which takes an array of sources. So that's what this is here. There's an array of source descriptors. So the source array, the size of that array. And then this is debugging. You don't have to include this, but you can give it a name. And this is for validation. So as you're going through and you're creating this resource, then if something happens while you're trying to create this shader for whatever instance, if you have a typo in your shader source, if there's a bug, if it won't link, it'll give you whatever error you need for the shader, and then it's gonna name this shader that you're trying to compile for you. So it's a debugging thing. Jamie asks, what's Gunslinger? Gunslinger is a header-only library that I've been working on for games, tools, stuff like that. C99. Let me make sure this compiles. I don't think I'm missing anything. Int to graphic shader or handle. So 77. What was that? So GS shader, I should come in here. Graphic shader, that is good. Oh, shader create, that's right. Okay, so looking at this, you might say, ha, what's up, Rick? How you been, man? Rick and I went to school together. We were on our senior project together. What have you been up to? What are you working on? So you might look at this and it looks a little verbose, right? And that's just because it's explicit. So again, it's an explicit pipeline that you're setting up all this data beforehand, similar to what you would in Vulkan or DX12 or something like that. And this works for multiple backends. The benefit of something like this is that for this, you could have multiple stages that you want to actually declare for your shader. So you could have tessellation in here, you could have compute, you could have multiple vertex shaders if you wanted, you could have multiple fragment shaders if you wanted, whatever you need in order to define your pipeline here. So it's up to you. That's the benefit of being able to do that. Okay, so we made our shader. Now we need to make the pipeline. So the pipeline is the last little bit. Find out where we do that. So the pipeline is what binds everything together and lets the backend know how to actually present your data. So we have this pipeline here. Pass in a descriptor to that. So the pipeline is made up of a bunch of different states. So it has a raster state, a blend state, depth state, stencil state, as well as a layout descriptor for the object that you're going to be rendering with this pipeline. So for the raster state, we're going to have a shader that's bound to it. And that's all we need for this. We don't care about index, so we don't necessarily need to set the index buffer stuff. And then we have our layout, which we haven't declared yet, so let's do that. So the layout lets the backend know how your vertex data is actually set up in your shader. Which in our case, it should just be a float 2 or float 3 for position. Which, since we're doing just a 2D triangle, we could just do this. Okay. Okay, we also need to set up this, but I'll tell you what, for now, let's just do this. We'll just do a red triangle, and then we won't need a uniform. Make this simpler. Okay, so the layout is our layout, and the size is the layout size. That should compile. Does, should run. Does, cool. Let's see. Good, been catching some of the streams on the replays. Cool, man. I was curious about the game engine, saw you run something new. Yeah, so this started out as kind of a work project. I needed something to easily do some tools that I was making for work. Open source it and just kind of been going from there. Kind of architecture are you trying to achieve? Maybe you could be a little more specific about that question, Jamie. I'm not sure what you mean by that. Doing cybersecurity for embedded systems? Cool. Awesome. I've gotten a little bit more into embedded stuff, Rick, actually. A little more hardware related stuff just on the side. It's pretty fun. Okay, so we should be good to go. Assuming we have this all set up correctly, which is a dangerous assumption. But for our update, so we have basic keyboard input stuff, and then let's just go to render. So how do you render? How do you do this stuff? Now that you have everything explicitly set up, it actually makes the render commands very simple. If you actually go into gs.h and look down here, these are all your render commands. This is all you really can and have to do. So we're gonna copy these and go, because they're more or less in order of how you do a render. Okay, so what you do first is you set up a render pass. So a render pass lets the backend know like how to clear your screen, which elements of the screen to clear, whether you're doing a depth clear, color clear, stencil clear, stuff like that. So what states you're actually setting up. And I'll go ahead and make this bigger. So let's see. It sets that up in the back end. Like what kind of states do you want to have happen for what you have bound? So you bind frame buffer with this. That's how you set up a render pass to, what frame buffer do I want to have bound with what render attachments, depth attachments, stencil attachments, stuff like that. And then you set up pass actions in terms of like what to clear. Do you clear the stencil? Do you clear the depth? Do you clear the color? If you clear either of those, you have certain values that you can assign to the actions if you want to clear that stuff. So the most simple, basic, why is my formatting so bad? Are these 3? No, it's 4. Interesting. Anyway, if you want like a really simple action, the simplest thing you could do is to just clear the color, right? So that's really all we want to do right now. So we're just going to set up a render pass action. With just a color that we're going to assign. We go over to GS. We actually look at what this is. So it's a particular flag. You don't have to set the flag. If it's default, then it's going to clear all these things, which is what we're going to do now. All we're going to do is we're going to set our color. That's all we care about. So we're going to assign this to a floating point value, and let's just give it something obnoxious so that we know it's working. So we'll do green. All right. So a couple things about this beginning the render pass. You pass in a command buffer. So the command buffer works so that you can pass commands into a buffer. It gets pushed back, and then in the back end, the graphics backends look through that command buffer, and it looks for opcodes, and then it does the actual actions based on the data. So the reason this is useful is mainly for multi-threading. So in the future, should you want to multi-thread your code, this makes it possible. If you didn't have something like this, then this would be doing basically anytime you made a call like this, it would be doing in-flight main thread calls to the GPU. So it would be impossible to do stuff like this on a separate thread if you wanted to. And then we're going to pass in a handle to a render pass. Now, if you just pass in an empty handle, like I'm going to do here, which empty is 0, then it's going to set it to the back buffer. So we don't need that. And you pass in your actions. So we'll pass in pointer to our action, and then the size in bytes, because it's expecting an array, but since we're just passing up 1, we'll just pass this. All right. And then we'll end our render pass with this. And then the very last thing to do, because this is the actual rendering stuff, is submitting the command buffer. This is where you actually sync up to the GPU. And it must be done on the main thread where you have the GPU context is created. Okay. And for that, we call submit command buffer with the address of the command buffer. So now if we run this, what we should have is our screen should be cleared to just a bright green. Assuming this works correctly. Render pass T. Let's see. That's right, because it's an action. It does not like this. Handle to, oh, that's right, because it's a handle of that. So it should be that. All right, there we go. So now we're clearing the screen to just a disgusting green color. And I'll look at chat real quick while you guys stare at this green. Let's see, Jamie says, or he asks rather, what kind of interface are you going for? How are you going to manage the entity data? How should the engine feel to use by the user? This is why I'm actually kind of hesitant to call this thing an engine, because it really isn't. It's a framework. And we were having this discussion the other day about what is the key difference between a framework and an engine. And it might be a semantic difference, but I think there's an important difference to make between the two. An engine really is something that makes a lot of assumptions and takes a lot of granularity away from the user so that there's a more convenience factor there. So stuff like making decisions about entity data, like what is an entity, right? What I consider to be an entity is probably, very different from what you do or anyone else in this stream. It's up to decision making based on what the actual architecture of the game is, right? The design of the game, rather. Or if it's not even a game, However, something like a platform layer is pretty consistent, right? You set up a platform layer, context, depending on the OS that you're on. You need to do certain things like opening, closing files, getting input states, all that kind of stuff. That's pretty consistent. Blending to the screen. Same thing with the graphics backend. You can keep that pretty consistent across the APIs if you write like an explicit renderer in order to go down to certain resources that are expected to be there. However, something like an entity, what is that? That's not a standard. Well, you can call it standard, but it's not a raw resource. It's not a universal thing, I guess. So in the core level of this framework, I'm not going to have things like that. I'm not going to have materials. I'm not going to have maybe necessarily graphics meshes, because again, how you design your shader, it decides what the vertex layout for the graphics mesh should be. I can't make that decision for you. So it's stuff like that that I have to be worried about, and I'm kind of trying to keep away from this as much as possible. That being said, I do have utilities that I've written on top of this core framework that you can use to simplify things. So in the previous streams, I've been working on, let's see, this immediate draw utility, right? So this kind of works similar to Legacy, but it uses this pipeline stuff in the back, but it allows you to do simple things like push raw verts. It allows you to do stuff like bind textures and draw text to the screen, draw primitives, stuff like that. I've also written an asset utility, which is a couple hundred lines of code, but it's a more or less a fully functioning asset subsystem. where you can, design your own assets and then push those into an importer, which holds your data. You can design a new importer to load files, stuff like that. And then register that into the asset subsystem that uses hash tables to look up based on your type, what the asset is. So stuff like that. But in terms of like entities, I don't know, man. I don't see that as a core thing that I'll include. I'll probably, if I do that, it'll be sitting on top of all of this, and there might be like a separate utility that says entity utility, But I'm kind of leaning more these days, towards how, like John Blow feels about entities, which is they're more or less useless. At least in terms of overall architecture and design in a general sense. I think they are... Entities were a solution to fix problems with OOP, but if people just weren't using OOP, then it wouldn't have come about in the first place, if that makes sense. That being said, maybe it's utility that sits on top. I don't know. Also, that being said, I do want to add stuff like loading in GLTFs, right? I think that's the main raw resource that I would like to have in terms of loading in complex mesh data. I like GLTF because it's an open format, it's widely supported. It supports pretty much everything that you would want to have in terms of animations, blend states, all that kind of stuff that something closed like FBX does. And I can still, I think, make it crazy enough to where, well, not crazy enough, but generic enough, which I hate that term, but, for the sake of argument, generic enough so that the user can decide what vertex information they want to have for the GLTF model. Let's see. Did you get a Raspberry Pi, Arduino? Are you still straight microcontroller? I got a few things, and I was actually working on a prototype project with a friend using my AR-15. So we were trying to do some stuff with that. What Windows version are you using? Isn't that the Vista Tuttleborg? I use 7. Because I don't like 10. Where was I? Simple triangle. Okay, so, all right, so we're clearing our screen, so our render pass is working. Now what we want to do, I don't necessarily care about setting the viewport, because the viewport is, it's going to be, whenever you create your platform layer, it's going to set to that naturally, so it's whatever. View scissor, I don't care. But we do want to bind our pipeline. So there's a couple things here. So we want to set up bindings, and then we want to bind our pipeline. So we're going to go ahead and do a couple of that. So this is our render pass action for clearing the screen. And then bindings for all of our vertex data, uniform buffers, etc. if we had it, okay, which we'll do that in a second. So what does that look like? Let's go back to this other example. Not this guy, you can go away, but this guy. So what does it look like to do bindings? I have those up here somewhere. This is all immediate mode stuff. Yeah, so you set up an array of binding descriptions, and then you set what that's going to be. Okay, so let me copy some of this, and we'll go over it. And we'll just get rid of all of this, except for the one that we're interested in, which is our vertex buffer. So again, it's an array of binding descriptions. You set the type for what the buffer is going to be, and then you set what the handle to the buffer that you're interested in is going to pass there. Okay. So let's bind our pipeline, which for it's just the handle to the pipeline, which is the pip that we created earlier. And then we need to set up our bindings, which is the fs binds, and then the size of the binds, which I'll just call that binds. And then the very last thing, once we have all this set up, is to actually draw what we have bound. And for us, we're going to start 0, and we have 3 verts that we're drawing. Assuming that compiles, and there we go. So there's our triangle. Okay, so this is working. Let's get rid of that color though, and we'll just clear it to like a dark gray. All right, there we go. Much better. So the couple things I might do in the future is maybe get rid of this and make it a little more implicit. So you just bind the buffer, and then in the back end, be responsible for knowing what type this is. So when you bind it, it'll just bind it. Maybe I do that. So instead it becomes this, so maybe it's a little simpler. Not entirely sure. Again, it's one of those decisions, right? So as you're making a framework, you need to keep in mind how much granularity you want to provide the user and how much you want to take away. However, there is an issue with this in that if you have something else like an IBO and you accidentally do this, this doesn't get resolved correctly. So that could be something that needs to be resolved on my end, because it's creating an ability for something to be done easily incorrectly, which isn't good. So probably something that I'll remove and instead hold inside of the buffer the knowledge of what type this is. I think I might do that. Okay, so if I zoom out, which is going to suck for the stream, this is 120 lines of code. Well, let's get rid of this. So it's 100 lines of code in order to do using the explicit pipeline setup, doing a triangle. Could it be made simpler? Probably. There are probably certain things that could be made simpler. So this is one area where, and this is to Jamie's point, where writing utilities that sit on top of this might be a further direction that I do take, where I do handle certain things in a more implicit and hand-holding way. So if you wanted some ability to say, load this mesh and you pass in, you know, a dot gltf, create material with a shader, and then create a model that is some mesh, some material and some mesh or something like that. Maybe that's something that I allow as a utility. However, this has certain implications that come along with it, being that in the shader, it decides your vertex layout. It has to, right? When you load the mesh, it has certain vertex attributes inside the mesh. It's a mesh description, right? So when you do a GLTF file or any OBJ or anything like that, it has certain attributes that are inside the vertex attributes, or primitive attributes is what they're called for the GLTF. So this stuff has to line up, or when you try to render, it's not going to work, you know. So this is something I'm going to have to decide how I want to set up so that it's flexible enough to work. But it eliminates eliminates some of the granularity in here for having to manually set up a lot of this stuff. Because otherwise, this is what you're going to have to do in order to like make a mesh, right? Get all the vertex data. You're going to have to decide how to set that up. Which again, you could do. That's why this framework is set up for that. But to make it a little easier to use, maybe get rid of some of the explicitness. Anyway. Okay, so here's our simple triangle using the pipeline. What's next? Let's go back to this guy. Yeah. Maybe simple texture loading. That should probably be the next thing. Okay. Done. Let's close this, close that. Hey VMA, welcome man. What is my description? Texture. See, load textures from file, explicitly construct GPU resources to use for the application. Okay. So this thing has a particular shader. So let's just copy that. So we have position, UV. This one has a model matrix. I don't need to do all this. Let's not do that. we just want our sampler, pass in the UV, and we're just going to do that. Okay. So we have a couple things that we're going to need to add into here. And actually just one is the texture sample. And then we're going to need, oh, am I in the wrong? Son of a bitch. See, simple texture. Oh, fuck it. Okay. Triangle. No. Yeah, I muted just for a second. Should be back now. Okay. So this is a sampler buffer is what we're creating here. Okay, and we're going to be setting up a quad for this instead. Let's see, Adam asks, should I be generating and compiling shaders procedurally at runtime? Currently, the way it works right now is that it takes shader source, what I'm going to be adding in the future. Excuse me, I'm drinking my coffee wrong. Is the ability to push up compiled spear V byte information, so you can do that offline. Jesus. However, for now, yeah, they take it takes just string shader source, and it's a GL backend currently. There's not a backend for Vulkan or DX12, so it's all GSL until those are written. Yeah. Okay, so we have quad data, and then we're gonna have an index buffer as well. So let's go ahead and fill this out. The coof. Yeah, I got the coof. So our vertex buffer is going to stay the same. We're just going to change it here so that we have positional data as well as UV data. And it's time to introduce index buffers. But John, it's also a graphics buffer. Yeah, it's all graphics buffers. Just like you would get in Vulkan. So then when we go to create index buffer, it's the same function signature. We're just going to change a couple things. So it's a buffer index, and then it's the iData instead. So there we go. Now we have an index buffer. Easy peasy. Okay, still setting up our shader. It's going to be the same thing. Here we'll call this quad, whatever, doesn't matter. Shit. Yeah, sorry, I had it on mute because I coughed and I forgot to press it. So what I was saying is what Jamie was talking about Vulkan being a nightmare. So this was the simple triangle. It's 100 lines of code to initialize and then render a triangle to the screen, right? If you've used Vulkan before, which Jamie, it sounds like you have, it's what, several thousand lines of code to do a simple triangle? So hopefully, even though this is an explicit framework, all the work is being done in the back end, right? So if I go to the, you should have sound now. All the work is being done in this back end to do all that stuff for you. Do you guys have sound now? Does it work? It should be good now. Adam's a muggle. It's okay, man. LWJGL is good. I mean, it's good for Android stuff, right? But again, so this is really the explicit shit that's done in the back end for you, because it's mapping that explicit framework down to this stuff, which is the implicit renderer for OpenGL, right? The reason I've set it up to be this way is that you have an explicit framework that works. It's easier to go from explicit to implicit than the other way around. The other way around is impossible. Well, not impossible, but it might as well be, as far as I'm concerned. Just wrapping your head around how to do that if you're setting up a framework where you want to provide implementations for different things. But yeah, go look at a simple, quote unquote simple example for setting up a triangle in Vulkan. It's definitely not 100 lines of code. And again, I'm trying to think of ways to minimize this, but still retain absolute user control over something like this. But really, this is probably as simple as it's going to get. But again, let's look at, let's do this. Let's create another example. Let's create, just for shits and giggles. So let's do an immediate mode triangle. All right. What do you need for immediate mode? So again, immediate mode is a utility that sits on top of everything. It sets up, if you actually go to immediate new, immediate draw, that's what it is. This should all look familiar to what we're doing now. So you're setting up explicit descriptors in order to create buffers. So we have one for samplers. We have it for uniform buffer, vertex buffer. We create texture, which we'll do here in a second. Shader source descriptions, all that kind of stuff. Setting our layout. We create all these different pipelines. So all this stuff gets done for you in this utility. So what does that mean? Well, you want to go use this. You include that utility. Okay. You still have to have the command buffer because you need to do that for rendering, so we'll have that there. But then you create an immediate draw utility object. And then get rid of all this stuff. Init that. Initialize the immediate draw utility. We'll still have that. We'll still submit the command buffer. Now we're going to draw a triangle to the screen. Okay, so we're going to set up a 2D camera. And then we're going to draw a triangle. Which, if we actually look at the source for that, we pass in the immediate draw object. I have a triangle V, I think, but we'll just do this. So where do we want the triangle to be? Let's do the exact same triangle that we just did, right? So 0.5, negative 0.5 to, so negative 0.5 to negative 0.5, 0.5 to 0.5, and then this will be 0, actually this is negative 0.5, and then 0, 0, I think, and then we'll just make it a white color. Or we'll do red like we did for the other. Why not? And then we pass in the type that we want to draw it, whether it's lines or triangles. I believe that's the function call. Yep. So render pass submit, where we pass in this guy. Pass in our command buffer so that we can join these commands up together, and then we pass in a color that we actually want to clear the screen to. So we'll just color, do like the gray, like a light gray again, or a dark gray. And then we submit our command buffer. See anything, probably because I have this declaration incorrect. Make sure I'm clearing the screen correctly. Yeah, okay, so that's getting cleared correctly, so that's good. That's right, because I have a 2D camera. That's not what I want. The 2D camera sets up, let's go back. If I didn't set this up, then I should get that triangle. And I do. It looks a little squashed now, so we should go 0.5 to 0 to 0.5. Yeah, so there's our triangle that we did. So this is, let's see, 17 to 49, so 20, so maybe 20, 30 lines of code to set up the immediate draw and then do a triangle, as opposed to this, which is the explicit triangle setup where you declare your shader and do all that stuff. And it's, 100 lines of code or so. So again, what I'm trying to do is provide the core framework to where if you want to dig in and do all the explicit stuff yourself, this stuff is there. And that's what the core will be. Sitting on top of all of that will be stuff like this, which is the immediate mode stuff, which simplifies it greatly, but that simplification comes with a price, right? The price being that you're not going to have as much control and granularity over the data. But if you just wanted to render a triangle to the screen, you know, that's there. That's possible. So hopefully that clears it up a little bit. But let's go back to textures. So I'm thinking for this example, so no thanks, I'll just play with my VAOs in the corner. Yeah. There's something to be said for that. Also, I would recommend not having multiple VAOs for your program. Okay. So let's do, instead of loading a texture, should this load textures? They do have a load texture data from file that is provided. Or should this show creating a random texture? I'm not sure. If I just create a random texture, I don't have to include an asset, which is nice. VAOs are expensive to switch, so the fewer you can have, the better. So if you're doing something like a VAO per mesh, that's where I'd recommend not doing it. In fact, the back end for this, for the graphics implementation, it has a single VAO for everything in this data cache. So the reason you have to have VAOs if you're using modern OpenGL, so anything above 3.3, you are required to have at least one VAO bound in order to do any draw operations. So what I do is in the back end, I create that VAO, have it bound, and then it runs for the entire duration of the program. And then what the user does is that they create vertex buffers that have their data however they want it aligned, however they want it declared, et cetera, and then bind that and use it, and then in the pipeline. So let's go to submit command buffer. Where you bind your pipeline, et cetera. Here's the draw function, so we do the pipeline, and then here's where we actually bind all the vertex attrib arrays and all that kind of stuff. See, Adam asks, so it's better to refill the entire VAO every time your geometry updates. Not the VAO, the VBO. So again, Jamie's correct. So the VAO is just attribute information, and it's just a loose pointer to all your vertex buffer information. However, for some reason, switching VAOs around is really costly. For some reason. I'm not sure why. So what you could do is have a single one bound, it'll work for the entire thing, and then you just bind your vertex buffers and then update the attrib array information, which is quick. Which is what I do. Okie dokie. Create a program that generates a random ppm and use that as a texture. Yeah. I mean, we could. Let's just generate a texture. Let's just do it. So, where do we want to do that? Doesn't really matter. Do it right here. Generate texture, and then we need to construct. Doesn't matter where you do this, but I'll just do it here. So construct sampler buffer. So when you do those two things. Actually, we'll do it up here. Keep these together. Generate texture data. And then create a texture. So I think I have some previous code with the texture that I generated, so I'm just going to use that. So I don't have to remember how I explicitly did it. So it might have been in here. Where did I do it? Yeah, it's this guy here. So just creating a checkered texture. So it's the row and column counts. And then we'll do different colors. So we'll do white for one part of the checker. And then we'll do like a blue, like a dark navy or something. And then here's our pixel data. So we'll just assign that to empty. And then for each row and each column, if I could type, holy hell. There we go. So we're going to iterate through rows and columns. And then there's a couple of checks that we could do in order to do a checker, right? So we want to make sure a couple of things. So we're going to see whether or not these are bulls. Whether or not our row is even or our column is even. Calculate our index. And then we're going to set the color at the given index using this fun little ternary check. So if our row and column are both even, we're going to use white. Otherwise, if our row is even, we're going to use the navy color. Otherwise, if our column is even, I think we're going to use white again. No, we're going to use the navy color. Otherwise, we're going to use white. Okay, that's how we generate all that texture data. Now we're going to create a texture. So in order to create a texture, we're going to fill out a texture description. So again, graphics, what is it? We actually need a texture to bind. And then we're going to assign that. So our texture is buffer create. This requires an address of a texture descriptor object. And then we fill out information for this. So our width is the row column dimension. Our height is the same thing. Our format, we want this to be RGBA8. It's the 32-bit. It's 32-bit color data, right? 8 bits per pixel. So that's our format. Our min filter is we want nearest. We don't want any filter for this because we want clear separation between those checkers. Same thing for the magnum filter. The data is going to be the actual pixel data. And then that's it. So that creates our texture. Int const gcolor t 64. It's probably just because of const. No. Fine. Let's see what's complaining about. Oh, I just have this, do this, otherwise this, do that. Okay. Just maybe not. Okay. So we're creating the texture. Now we need to create our sampler buffer. Again, the uText is GF graphics. Buffer create. And this actually requires a sampler description. Which, if we go to iDraw, we just need to pass in the type of the sampler. So we'll have different types. So whether it's a cube map, or it's a sampler 2D, or whether it's a 3D sampler, stuff like that. But this is really all we need for this. Let's see, buffer description, sampler description. So this is the data. All right, so we actually need to fill that out. So then the data, the type for this. And then you give it the name of the actual sampler that you want to use. Okay. So what this does is it actually links up the uniform name, which is utex, to here. So now all we should have to do is we've created all this information, created the pipeline, which has the layout. Is we need to set a couple things. One being the pipeline so the layout, the index layout here. So we actually need to set that out. Where do I set that up? Index buffer element size. Yeah, that's what I need. So the raster dot index buffer element size. So we're going to pass in the size of this. If we look up here, we're using U32s, so we need that for our stride. Set up U32. And then down here where we're going to bind, we want to bind the index buffer. When we do that, we should, let's see, yeah, down here, it's actually 6. So we should have a quad now, and we do. But it's black, and that's because we're not binding our sampler. So I'm going to bind the sampler buffer. The buffer that we're doing is the actual sampler buffer, which is what is it? Utex. And then the data that we want to bind to that is the handle of the texture that we created, which is text. I think it's the address of the text, actually. Yeah. There we go. Let's see, Adam asks, are you abstracting meshes and materials? I'm going to create utilities on top of all of this that does that. So this is the lowest level that you'll go in this utility, or in this framework, which, as you can tell, really doesn't hold your hand. You explicitly declare all the data, you do all that stuff. You know, it's a step above writing direct Vulkan or DX12 or OpenGL code, right? That's the idea of this. That's all it is. That being said, there's going to be utilities that sit on top that abstract some of that even further that you can use optionally if you want to. I haven't decided yet how I want to do that. But there we go. There's our checkered texture. So a little more involved, right? But we're creating a texture dynamically, creating our texture object, creating our sampler buffer. Then we've updated our vertex definition or vertex data so that it's a quad instead. We're using an index buffer now. But other than that, pretty much the same as what we had for the triangle, right? And we can come in here and we can change some parameters. We can make this a pound define actually. Now it's 100 by 100, which I'm sure looks great on YouTube. But we can make it a 10 by 10 instead. Okay. Alrighty. Since Gunslinger is 2D, are you planning on adding 3D support? It's not 2D. It's not a 2D engine. Zero. Radius, color. Not a 2D engine. Actually. So, I'm not sure if you could see that. Let me move it back a little bit. Yeah, I did 0.2. There we go. Just for clarification, there's no such thing as a 2D or 3D engine, guys. There's no such thing. There, I'll be right back. I'm gonna get some more coffee. Okay. Okay, can you insert your own 3D models? Or only let you add 2D quads? Oh, it's two different questions. Can you insert your own 3D models? Asks Amazinger 01. So no, not for the immediate mode. Immediate mode is mainly just for debugging stuff. So in previous engines I've worked on, you typically have some kind of debug utility, especially for stuff like physics and whatever else. So it's an ability to do that. I've thought about a way to be able to add custom models into this. The issue with custom mesh data, guys, is the mesh data itself has certain... It has to work with... Like, you can't separate shader from mesh. You can't do it, because the vertex declaration is inside of the shader, which is the layout, which tells the renderer how to actually display the vertex information, right? So it's kind of difficult to do that. So I've been trying to think of ways to be able to do it, but it might be a mismatch entirely. Maybe not. I don't know. Maybe I had something into the immediate util where you could create some kind of higher level mesh declaration that I provide. You could use it and then quickly do something like that. I'm gonna have something like that. I don't know what it looks like. And again, it's not a I don't know how to do it kind of thing in terms of technicality. It's I don't know how to do it in terms of where does it fit? Where does it belong? So it's a design issue more than anything. Yeah, you can make a global shader, but as soon as I do that, I've taken granularity away from you. So this immediate mode, I like it because it sits on top. It's optional. You don't have to use it. And it's very explicit about you can't change the shader for this, right? If I go into the immediate mode shader, a shader that works for any mesh doesn't exist. That's not a thing. Why did that freeze? Right. If your mesh declaration has, like, here's a mesh layout, right? It's expecting this mesh layout or this vertex layout, right? If you pass in vertex information that doesn't follow this vertex layout, doesn't follow the particular stride that you tell the GPU to use, doesn't follow certain offsets for the stuff, it won't render correctly. It can't. It'll be garbage. So saying a shader that works for any mesh, that doesn't exist. It's impossible. Does that make sense? What's your favorite 3D file format? I'm gonna support GLTF inside of here. I like it. I was talking about this earlier. I like it because it's an open format. It's easy to parse. It comes in both binary formats as well as GLB, which is a binary format, which is GLB, and also comes in a human readable JSON format, so GLTF. And I think I can make something that is, again, quote unquote, generic enough where you could pass in, like I was doing sketches for this earlier. In here, do I have it in here? Yeah, so I was doing sketches earlier for, because I was looking at CLGTF, which is a fairly popular, from what I could tell, header-only GLTF loader, right? So it takes care of parsing the JSON for you, which is a pain in the ass, and then it takes care of actually grabbing this data so that you can use it however you want. So inside of GLTF, I was reading the specification because I'm used to it. I'm getting used to it. It has stuff for like a position, a normal, and a tangent. These are all single declarations basically, and then you have other ones which can be enumerated. So text chords, colors, joints, and weights. So I could have something like this where up to a certain amount you declare position, normal, and tangent as a mesh attribute type layout. And then you have joints, weights, text coordinates, and colors, which could be up to a certain number. I don't know what that should be. Trying to figure out the best way to do this. So then if you know your GLTF data, you know what it needs to look like, you could actually pass it a mesh attribute layout to the loader, and then it will grab those particular things for you and push that into your mesh data. Maybe I could do something like that. I'm interested in OGL with C. How'd you go about all the matrix math? Is there a common library people use? I wrote my own, but yeah, GLM, people like to use that. And there is a C API for it, so you can use that. Under Gunslinger, is there a third-party library to create windows? Did you code it yourself for each platform? I use GLFW in the backend. It's header only and include. However, it's a particular implementation that you can write your own. So inside of the platform implementation, it just looks for a particular implementation to find, and then it includes all of that and does it. However, if you want to do something like platform Windows, platform OS X, platform Raspberry Pi, you know, stuff like that, you'll have to create your own custom default or custom implementation and then use that, which I'll be doing for Raspberry Pi, doing for Android, stuff like that. I think the next one that I want to do actually is WebGL. So I'm going to need an WebGL graphics backend and then have something for HTML5. Because it would be cool to be able to do like Raylib does, which is have a way to have a in the GitHub repo link to examples, but then have those run in the web. Which would be neat. Yeah, dude, I want it running on the Raspberry Pi. Like I was talking to Rick earlier, again, a guy I went to school with. And he does embedded stuff, and he was our hardware guy. And I've been getting more and more into hardware, especially for like home automation stuff. And it would be cool to be able to have Gunslinger running on Raspberry Pi with some like small utility UI that I've written for whatever the hell I'm working on. Like it'd be cool to be able to own that entire stack. So that's where I see this going anyway. Okay, so yeah, I'm thinking about this. So today was either writing some of these examples and then porting them over to the new stuff, or it was working on GLTF loading and then getting this working. Some guys in the Discord recommended that I do the former rather than the latter. So that's where I'm working on the example stuff. Because the idea is that, you know, if you want to use it, you should know how to use it. I've never used TinyGL, so I don't know. It might be. Okay, so simple texture. Load textures from file. Which we could do that. So if you wanted to actually load texture data, we could do that as well. You guys want to see how to do that? Load a texture. So if we had let's call it text 0. Simple texture. Let's create an assets folder. I'll show you all how to load stuff from file. Let me find a good texture. There we go. Okay. So we'll load in this texture. To do that, I see that GLTF has text in it. Yeah, so GLTF is a JSON format, and GLB is a binary format. So we create this, create that. So create a dynamic texture. And then we'll load texture from file. And again, I have a utility to load textures from file, load texture data from file. Load texture data from file. We'll give it the file path, which in our case is assets IU.png, I believe. It is, and then we want to pass in a pointer to width. So let's just cache these up here. And then our data. Okie dokie. So there's our width, our height, number of components, address of our data, and then whether or not we want to flip the image on load. Typically, yes, you want to do that because OpenGL has the UV coordinates flipped from something like DirectX. So I tend to flip my texture data whenever I load it in, and then that way I don't have to flip it in the shaders. Do whatever you want though. So we loaded the texture data. We can check to see if we're loaded. I don't really care. So actually, I'm not even going to cache that. And then we need to create our texture. So text 0 is graphics texture create. Which actually, we can reuse this texture description. So we'll just set all this. Okay, and then we can just pass in that. Actually, I don't want to do that because I like the initialization this way. It's faster. Not in terms of speed, but just in terms of I don't have to rewrite stuff. So our width here is our width. Height, again, we're RGBA8. I want linear filtering for both these two. And our data is going to be our data. And then when we're done, let's go ahead and free our data. So clearing stuff up. So now we're compiling that, except I'm in the wrong code. Good, simple texture, good. Okay, so we're creating this, no problem. Now let's go ahead and let's create another, well, we could do this. So for a bind, we just set this to text 0, and now it'll bind that instead. And there's our texture. So let's see. Amazin asks, once wrote an STL parser, okay, parsing STLs, and it took a really long time to load in OpenGL. 6 seconds for 6,000 vert mesh. How would you do it faster in yours? I mean, if you're parser, that's just a parsing issue, right? So one thing you do typically is you have some way to be able to pre-process raw resource data into something more usable for your engine to use or your game to use or whatever. That way you don't have to do that. So if you have a raw STL file and you want to use that, you have to parse that, convert it into a GPU mesh, and then push that up. So what you can do instead is take that information, parse it, convert it to your GPU mesh, and then dump that mesh data out to a binary file. And then from then on, all you have to do is just upload that binary file, which it looks like you do there. So my solution was to dump all the mesh data into a binary file. Yep, that's the solution. That way you just load that up, dump all that data into, you can just dump that data directly into the GPU. Done. There's no parsing involved. So do you, Adam asks, do you interleave your vertex data in one VBO? Yeah, for this I do. What I'll do in the future is something like what Sokal does, which is give you the ability to decide whether or not you want to have interleave data. If you want to have non-interleave data, you can set the offsets, you can set the strides. So have complete control over the vertex data declaration. All right, so now we have a way to do that. Let's do a blend of these two. That, and we'll blend it. We'll just do a half blend. So we're going to need another sampler. Okay, so we have a new texture sampler we're doing. And then down here, when we bind it, we're going to have to be more explicit now. So we actually have a binding that we need to set. And that might be kind of tough to see, but we're actually doing a blend now between those two images. How do you make this simpler? Well, we could use the asset system instead. So there is something, there's a texture asset. So let's go look at that. Oh, come on. which holds a description and it holds a descriptor. And then there's a texture load from file. Okay, so GS asset texture load from file. So now this should look familiar, right? So it's doing all this description stuff for you. You decide whether or not you want to actually keep the texture data, which again is useful for like an asset system. If you want to serialize texture data out, you could do that. And then it calls into that util directly with all this stuff. Fills out the descriptor, sets that for the texture, asks the graphics backend to create a texture for you, and then sets the handle. And then that's it. So what you could do is we've declared this. We can come over here, instead of creating this and loading all this directly, we could do this instead. Where we pass in which I believe is what we called texture, right? Yeah. And then whether or not we want to keep the data, we'll just say false. We don't care about keeping the data. And so now that all boils that down, or as Casey Muratori likes to say, compresses down into a single call. But ideally, still keeps the granularity that you had before, so you can be explicit with it. And that should compile. The only thing is that we're not using it down here, so we actually need to do that. So it's the same thing. We've just compressed it a little bit to make it a little simpler. So, yeah. Okay. So there's a couple ways to do this. I'm not sure what I should keep in here. Do you load unused vertex data to batch it with other meshes of a different format? I'm not quite sure what you're asking there. I think I know what you're asking, and that really wouldn't be possible if I think I know what you're asking, but maybe you could ask in a different way, so I make sure. Okay. Okay. All right. Maybe this is too complicated. I don't know. But we're going to run with it. What I also thought about doing for examples is going through learnopengl.com and then just recreating some of these. Man, this is bright. So, you know, simple triangle, constructing shaders. So what does he do for this? Although, I mean, hello triangle, you kind of have to do that. Kind of have to have a shader, bro. Yeah, so. It's kind of hard to take away some of the complexity at certain levels. Because this complexity involves loading textures as well as creating them. So, which if you're starting out from nothing could be complicated. If you have one mesh with only positional data, would you add, say, a white RGB value for every vertex so you can put it in the same draw call as another mesh? So in the immediate mode stuff, I do make that assumption and take away that control. But that's because I know how that data has to be laid out in the vertex declaration for the vertex shooter. I can't do that generically for everything else, and nor would you want the backend to do that. That would be frustrating as hell. But for the immediate mode stuff, yeah, I make that assumption. So whenever you actually call GSI v any of the vertex functions, then what it does, it creates an immediate vertex, which is a particular vertex layout, has to be. And it fills in 3D positional information, fills in UV information, fills in color, and this is depending on what's cached into the immediate mode object, and then it pushes that vertex into a dynamic array. I feel comfortable making that assumption because this immediate mode, again, is optional, and it's made with the assumption that you're using it in a particular way. Here's the shader for the immediate mode, by the way. This works for lines. It works both for lines as well as triangles. So any of the primitive types, because it's filled out in a particular way. But again, the vertex layout, as you can see here, it's going to be, you know, a float 3, a float 2, and a float 4. you have to fill it out that way, and the vertex data has to be strided a particular way, and the offsets have to be set up a certain way, or the data is going to be garbage pushing into this. Okay. Let me get rid of this. Well, I guess I could add more into it. Instead of being immediate triangle, I could just immediate draw. Well, no, let me rename it. Of course not. So I could probably show off the different stuff in here. But this could get kind of crazy. So again, with the immediate mode stuff, it has a lot of utilities that you just don't have to worry about setting up yourself. So if you wanted to do a rotating sphere and then draw text to the screen, you could do this. So let's say 100, 100, we want to do text that says, I don't know, what's good text? Sample text. Let's just do white. So we can render sample text to the screen using this. Again, useful for immediate drawing stuff. This could also be done in 3D. We don't do any defaults actually. And then we're in 3D, so we need to flip this. Zero, zero, sample text. Oh, what's the problem? It's probably face culling being enabled. So gee. Actually, that shouldn't be a problem. But it is huge, so So with the same call, we just set up some different stuff with like some of the perspective matrices in the backend for the immediate mode. And now we have 3D text that's rotating inside of. Rotating inside of our sphere. Crazy town. Mr. King Champ asks, how much experience do you have? Like a decade in industry and a little bit before that. Adam says, right now I'm checking what data each mesh uses before loading it into a VBO, and then I have to switch shaders for each unique vertex layout. Right. So that's basically what pipelines are. Right, because the shader is king. It designates everything for the pipeline in terms of what actually gets drawn and how the vertex data that you push up is going to be actually used. Make this bigger. Make it bigger. Nintendo, hire this man. No thanks. I don't want to work AAA. I've already turned down AAA offers. They have too much control. Which is a shame, because a lot of former colleagues and good friends, you know, work in AAA, and it'd be fun to work with them again, but how expensive is it to switch shaders? I don't know, actually. It's a good question. For Vulkan, switching a pipeline is extremely expensive. I imagine for OpenGL, it's somewhat similar because a lot of state has to change to bind shader programs. But, you know. So I don't know what the immediate mode sample would have in it. What that should look like, but you can do quite a bit. For those of you who have not seen the other stuff, where did I have this? Projects, is it in the refactor? It is. Can I do them? Okay, cool. CD proc, CD, no. Vim, compile. So let's do, I don't know. Which one do I want to use? Test main, asset main. I think asset main had pretty much everything that I wanted in it, so we'll use that. So like this is kind of an example of how extreme the immediate mode stuff can get. Just to show you what's possible. which I don't know if the frame rate looks like it's dropping a little bit. It's not. I mean, you can tell I'm displaying the frame. It's running at 16 milliseconds consistently because I've got it VSync bound or locked, VSync locked. But I mean, I could do something this crazy for the example, but I don't know. Maybe I should split up the immediate mode stuff into its own category and have a folder for immediate mode examples and then go over all that utility stuff. The issue is because there's a lot that's possible right now just with the framework itself that it's difficult to figure out what's the best way to show it off and make it easily accessible to people. So I don't know. I also probably just got a copyright strike because that is playing copyrighted music. But I have the license to it, Susan, so back off. How should a beginner start with computer graphics? I would say start with Opengl. Be fairly familiar, fairly comfortable with C or C++, one of the two. I prefer C, obviously. Start with Opengl. You can go to learnopengl.com. Start there. And just kind of play around with the examples, go through the tutorials. He's got a lot in there. Also, if you sub to the channel, I've already started writing out an outline, and hopefully soon we'll start working on an actual Opengl tutorial series. I'm able to render cubes. There you go. You're most of the way there, man. But yeah, so I'm gonna do an Opengl tutorial series. It's gonna be C, and the outline. I think I have it somewhere. Can't remember where I put it. Yeah, here it is. So the outline's going to cover quite a bit. So setting up your platform, it's going to work for Windows, Mac, and Linux. We'll go over just setting up a context, and then we'll do an introduction to GPU pipelines using modern Opengl. So it'll cover 3.3 up to 4.1. Then we'll go over shader creation, all that stuff, how to debug your shaders, well, when you create them anyway. And then we'll do simple stuff. We'll create vertex buffers, go over all of that, set up blend equations, do texture samples, samplers, explain what those are, how UV mapping works, give an introduction to basic linear. Probably we'll use GLM because I think writing a math library will be out of the scope of this, so we'll just use something. We'll go over common spaces, that you'll need to know in order to get familiar with graphics programming, and then start just going into more advanced topics and stuff like this. There aren't any videos that cover this kind of stuff, really. So how do you do like frame buffers and render targets, basic lighting? I think there is one guy that does go over quite a bit, especially when it comes to post-processing and stuff like that. And it's he does Java tutorials. I can't remember his name, but he's also an indie developer. So he does some stuff that's kind of similar to this. But I'm going to do it in C, the way God intended. And then, yeah. Adam says, I have a spinning Barry B. Benson model with Obama textured. Cool. Okay, but yeah, that's the plan. So I have a few videos that I'm working on right now. I know it's been a while since I've updated one, but that's because I've been working on this stuff. And you know, I can only do so much. Thin Matrix, thank you, Ethan. Yes, that's his name. So he does good stuff on OpenGL, but it's Java specific, but yeah, all hell Terry. Yeah, but it's Java specific, and I don't want to do that. There's no one that does good C OpenGL tutorials, and then covers all the more complex modern stuff. So I'd like to be that guy. I want to be that guy. Okay. So, are there any resources you recommend to getting into working with OpenGL? Yeah, I'm going to type it. So, go there. Okay, so this is a bit complicated. So let's make it simple. We don't need to make it so complicated. Right, boys? So let's just do a simple texture. Stop being complicated. There you go. Ruben knows what's up. I don't want to load it from file because I want to show you how to actually create a dynamic texture. So we're doing that. Okay. I like Cherno. I think he's very charismatic. He makes decent content, you know. I think it's contentious to say that, I guess, but I enjoy him. He does certain things that I disagree with vehemently, but I still enjoy him. And that's what counts. So let's see. Yeah, GS examples. Simple texture. Thank you. Good to go. And there's our texture. So I think I'm gonna keep it as simple as this. We're gonna create a dynamic texture, fill out texture data. And then, yeah, okay. Okie dokie. I think I'm probably going to end the stream here in a second, but gotten quite a few people that showed up. Thanks, guys. I appreciate it. Be sure to like and sub. Keeps me motivated to keep going. Keeps me motivated to do tutorial stuff, that's for sure. And it seems like that'll be a direction this channel will probably heavily take, because I think a lot of people are beginners who come to the stream and they want to know how to get started and how to do this stuff. So I'll probably gear a lot of the content towards that and split it between continuing to work on this framework, because I would like people to start using this. Although if you're a beginner, I understand this is a deep dive and it's not going to be that easy. So, yeah. But I also do have a plan or plans to make a video covering this in a little more depth. I think the next game engineering video is going to be covering this. So look forward to that. In anticipation of working on that, I might not stream for a second, so I can actually work on that video. But yeah. Okay. Well, I will talk to you guys later. Procedural 2D pixel art, roguelike, and Unity, so original. Yeah. Well, I mean, people do what they want to do. I just enjoy making this stuff from scratch, you know, to whatever extent that is, to a certain degree. So. Okay. Well, how do you focus with pings? Usually it's not that bad, but it is what it is. Okay, guys. So I'll talk to you later. Again, like and sub. Join the Discord. If you're not in the Discord, get in there. It's where all the cool people are. You want to be cool. And yeah, and then I will see y'all later. All right. Peace.